Find the vertices and foci of the following ellipse. Graph the equation. Our equation is x squared over 9 plus y squared over 36 equals 1. Before we start this problem, I want to take a minute to look at a picture of an ellipse and make sure we understand all the features. Now, at the top here, I've listed equations that represent the two different orientations that we're going to focus on. And the two orientations are horizontal and vertical. And the reason why I've labeled them in this way is based on the value of A. A is always going to be the longest of the three of A, B, and C because it's the distance between the center and the vertex. So when we look at one of these equations, if we see the larger value under X, we have a horizontal orientation, or the larger value under Y, we have a vertical orientation. I'm showing you a picture of the vertical orientation, and I want to point out just a couple key features. I've already mentioned the distance between the center and the vertex is A. The distance between the center and the minor axis vertex is B. And then we have the distance between the center and the focus is C. If I draw a line connecting the focus with the minor vertex here, that creates a right triangle. And we can figure out that this distance along the hypotenuse is A, the same A that is the distance between the center and the vertex. And that's where these equations come from right here. Because we have a right triangle, we're able to relate the sides of that triangle with Pythagorean theorem. So we get that b squared plus c squared equals a squared. Now getting back to our question, we want to find the vertices and foci of this ellipse. And with this equation, I can see that the larger number is under y, meaning that I'm going to have a vertical orientation. So the 36 will match with a squared, and so that means that a is 6. Then 9 will match with b squared, so that means that b equals 3. And I can also see that there are no numbers added or subtracted here, so this ellipse has a center at 0, 0. I also want to find the value of C so that I can locate the focus. So I'm going to use this equation, b squared equals a squared minus c squared. So b squared is 9, a squared is 36, minus c squared. I'll subtract 36 on both sides. 9 minus 36 is negative 27 equals negative c squared. I'll divide both sides by a negative 1. That gives me c squared equals 27. If we square root both sides, we get that c equals square root of 27. I'm ignoring the negative because c is a distance. We could simplify this. 27 is 9 times 3. So c equals 3 square root of 3. I like to use the picture to help me figure out where the vertices and foci are. We have an ellipse that has a center at 0, 0. And since A is 6, and this ellipse is vertically oriented, I'm going to go up and down 6 units from the center. Up 6 and down 6. So I used the fact that the orientation was vertical, as well as the value of A, to find the location of the vertices. So I have 2 vertices, and those are at 0, 6 and 0, negative 6. Now the foci will also be located vertically up and down from the center. And I put in my calculator 3 square root of 3, and that's approximately 5.2. So I'm going to go up and down from the center about 5.2 to about here and here, and that's the location of my foci. So my foci will be at 0, 3 square root of 3, and 0, negative 3 square root of 3. Then I'm going to use the value of B to show how wide this ellipse is. So B is 3. So I'll go 3 units away from the center, left and right. And now I can sketch the graph of the ellipse, passing through the vertices and the minor vertices. Thank you for checking out my videos. Have a great day.